I've opened a lot of notebook. Let me close it and let me just stick to one particular notebook. So this is the already existing notebooks that we have. That is for the sandbox. Once you log in and you go into the real world examples, you have a lot of existing notebooks within the system. So the normal procedure is to load the packages. As you can see, there are a lot of already packages that, because this is an existing notebook, and the purpose of this notebook is to is for water extent. All the functions that you will need is already actually uploaded into it. So with this particular notebook, we run the steps. And let me clear everything from the kernel so I can go step by step and give the tricks ahead. So you just click on it, then everything will be uploaded. The main reason why we have the matplotlib inline here is to help you so that when you display something, you actually be able to figure it. You actually be able to see the end results here. And these are all necessary models or packages that we will have. Then we have a particular function here. We won't talk much about it. Then the next thing is to establish the connection to the data cube. The establishment of this connection to the data cube is very, very, very important. If you don't establish this connection, there is no way that you'll be able to get access to the database that which contains the satellite imagery. So these books is very, very important for this connection, for you to be able to establish the connection between the database and the sandbox. So this session is also very important. The water underscore extent is just a name that is actually given to the platform to make your notebook unique. It can be any name. And mostly what we advise is use it for the purpose of the notebook. Your goal of the notebook should be the name that you can actually have it here. So because this notebook is actually made for water extent, that's why we actually name it water extent. But if it is a time series water extent, you can actually change it to time series. It all depends on how you want to do it. Then the next step is to create the local DAS cluster. So that actually makes it easy for you to run your data very quick, especially when you are trying to load the data. That is for loading of the data. To load the data and you want to see the results very quickly, we use the DAX to upload the data so that you actually see the end results very fast. Then the next part is to define the area of interest that we are working with. Because this is an existing notebook that we actually work with, the area of interest has already been defined for a particular area, which is Lake Sulanga that we are working with. But if you want to change the area of interest to a new area that you want to work with, you can actually change it using these tools here. That's the lat long, the lat buffer, and the long buffer. The most important thing here is actually the lat underscore range and the long underscore range. Why am I saying that? Because for you to work, we need the upper bounds of the image and the lower bound of the image to be able to identify the area that you are going to work with. How can you actually do that? So you want to use an example for an area that you'll be working with. So to find your area of interest, normally it's best to go to the maps.digital.africa area, where you can actually get access to the areas of Africa. So I want us to search for a place, my favorite place, Lake Edward. It's actually named after me, so I prefer to use that site. And it's found in Uganda. So that's the lake that I would like us to use, the Lake Edward. So as you can see, this is the area of interest that I want to work with. So how do I define my latitude and the longitude? We'll go through the 2 steps. The first step is to get your upper bound, which is this side, and your lower bound, which is that side. With the upper and the lower bound, you'll be able to get either a rectangular or a square depending on the area that you are going to work with. So how do I get my upper bound? Is to select a point from this area. So once I click, you will see that the coordinate system will show up here. Then I can copy it out. So copy it. And when you come to the define the area of interest, you can create another space there, then paste it there. For you not to get confused, you can actually make it a type upper here. The way you've actually put it this way, if we run it, you get an error. So let's run it and see. So it's an invalid syntax. What it's actually trying to tell is that what we've put here is not executable. So to prevent that, the best thing that we can do is to comment it out. Then after getting the upper lat and long, the next thing is to get the lower lat and long, which is going to be the top bottom right. So just gauge and look at the area, then pick the bottom right perfectly. Then you can select it out. Then you can still copy it and come and paste it here. Then you can name this one lower right. Okay. So right now that we've gotten the extent of our area of interest, we can actually copy this area because that's actually the most important thing that you'll be needing. Because you're not going to use these particular functions below here, we can comment it. And the way to comment it is to use Shift Hash, which is the tray. So once you use the Shift Hash, you comment all of those sections out. If whether it's a function or a variable and you don't want to use it, the best way to do is just to comment it out. Now, how do we define our long range? So the lat range and the long range. So the lat range and the long range actually pick the upper latitude and the lower latitude. And the long range also pick the upper longitude and the lower longitude. So how is that done? So, you know, from the coordinates that you pick, we are starting with the latitude. So you have the upper. So you pick the upper latitude. Then we just change it to here. Then you pick the lower latitude. And we change this whole here. Then for the upper longitude, you pick the longitude here. Then you paste it here. Then the lower longitude, you pick it here. Then you also change it there. Okay, so we've actually defined our latitude and the longitude. So we can now execute we can now execute it. So right now, you've actually identified the lower bounds and the upper bounds that we want to work with. We'll come back to the area of interest again. If you want to use the centroid, how are you going to use that section again? Now let's display the results and see what will happen. Okay, so one of the things that we can normally do is, you see the results here, the display map. The display map is a function that actually helps us to know to display the area. But if you want to get much information on this display map or on a particular function, the best thing is to use the Shift tab. Once you click on the Shift tab, it gives you enough information on how that particular function works. So you can look at the display map accept X and Y coordinates, which is mandatory. And the default coordinate system is the 4326. The margin is -0.5 and the zoom bias is equal to 0. So these are the parameters that are available for the display map. So if, for example, you want to change the zoom bias, which is actually 0, you can change it to another value. You can actually make it 4. So there's the display map got an unexpected zoom bias. So I think let's go back and check the spelling of the zoom bias. Yeah, I changed it. It's that. So just telling me that the parameter that I provided, it doesn't exist. The error was because I misspelled it. That's why I had this error. Then let's run it again. Wow. So you see how it actually zoom into the surface. So although I have my parameter here, but because I use the zoom bias, it actually zoom within the area that you are working with. So with the zoom bias also, you can actually change it back to 0. Yeah. Like Edward is what it was of interest, but the area that has been displayed is different. Why is that? Let's go back to our area of interest. Oh, yes. So the issue was the latitude. Okay, so actually I changed it. So the latitude was the one in front, so I can change it here. Then I can replace it here. Perfect. Then you notice that the latitude is X south. That means it has to be negative. So also we have to be also careful when we are defining the area of interest, because the lat long, the west and the south are always negative. So for this thing to take effect, you have to rerun that particular cell that you are just running currently. Let's rerun it again. Then let's display it again in the Zoom extent. It actually takes some time, but it will load. Oh, voila. So we've actually gotten the extent of Lake Edwards from the area of interest that you are working with. So we're actually within that particular region that you are working with. So this is one of the ways that you can actually draw to the area of interest that you'll be working with. Next week, by this time, so we'll be talking about how you can actually also use the shape file to, if you have the shape file of the area that you want to work with. Next week, we'll talk about how you can also use the shape file to just draw to the area that you'll be working with. So next week, when you come, you'll be able to have that idea of how you can also use the shape file to display the area of interest you want to work with. So this is one method by defining the upper bound and the lower bounds of the area that you want to work with. What is the other method? The other method is also to use the centroid point, which is already mostly is the default point when you actually enter into a particular notebook. So how is that also done? You can go back to the maps because you've already identified the area. Then you pick so looking at the diagram, you can pick the centroid point of the map, so which we have here. So you can copy it out, don't want to miss it. Then you paste it somewhere here. And you mention it as centroid. Please remember to comment. If you forget to comment, let's see what will happen. So I forgot to comment about that. Let's see what will happen in syntax, because the system doesn't understand what you just put there. So it's always good to comment out points which you won't be using it. And because this time you're not going to base on the long range and the lat range, you want to be based on the lat here. So you will uncomment this session, then we will replace it with this lat that we have here. Have minus, you paste it. Then the long that we have here, you pick that one and also replace it here. The next thing is to identify our buffer. So how do we identify our buffer? You can use the measurement tool here, which you will pick. Then you can actually draw a line from here to any point here. So here we have about 31.80 kilometers for our latitude. Then you can draw another line. You can pick and draw another line from this side to maybe upstairs here. So we have about 29.88 kilometers. So we have one for the lat, we have one for the long. So you can actually take notice of the distance also. So when you come to the lat buffer and the long buffer, here by default is 0.2. But when you look at it, you notice that the lat buffer that we had was 38 kilometers. So you can type that 31.80 here. Then the long buffer that we had was 29.88 kilometers. But the lat and long are in degree minutes, seconds, like they are in degrees. And what the distance that you are comparing is actually in kilometers. So how do you compare kilometers to degrees? That's so 1 degree is approximately 111 kilometers. So to convert this one to degree, we just divide them by 111. So right now that we have this side, you uncomment this section also. So based on the centroid and the latitude buffer and the longitude buffer, it will actually define our extent for us automatically without us going through the step we did previously. So now let's execute it and now let's display the map. We still have the same results that we did. So if you are using the latitude and the longitude, these are the two processes that you can actually use to identify the area of interest that you are going to work with. Please, any question before I continue? Okay. If no other questions, then we will continue. That means to identify the area of interest if all of us are on the same page. Then the next step is to load our satellite imagery. Loading of our satellite imagery, first of all, you already have an existing query here. So we have the X, which is going to be the long range that you've already defined at that top this session. Then we are going to have our Y, which is the lat range, and the resolution. The resolution is also very, very important because depending on the satellite imagery that you are trying to use, if you are using Landsat, it's actually 30 by 30. Sentinel is 10 by 10. But sometimes, depending on the area, if the area is big and the memory size that you are having is very small, you can actually downscale the resolution so that you can actually have a bigger area to compute. And for this, doing that resampling is very simple in the notebook. You just have to change the number. So if I want to do an upscaling, I'll just change it 20 to a pixel of 20. I'll just change it to 20. The system will automatically do the upscaling for us. If I want to increase it, I can downscale it. I can even change it to 1000 by 1000. The system will automatically do it for me. So there isn't a need for you to worry about how the scaling is going to be done. And everything has already been aligned, so you're not going to have a problem. We also have the output CRS, which is the coordinate system that you'll be using. Then the time zone. The time zone is the start year and the end of the year of the series that you want to work with. So one of the tricks that I also want to make mention here is if you are dealing between 2 years, if you are dealing with only 1 year, you can actually, let's assume you are dealing with 2015 only, you can actually type 2015 in a string. Automatically, the system will know that you are working from January 2015 to December 2015. So it will do that query for you from January 2015 to December 2015. If you are interested in only 1 month in 2015, going to be 2015, then you only bring the month. That means you're only interested in the data sets in January 2015. If you're interested in June, you just change it to 6. You only have that one. So you don't actually have to define all the time period. Like if you're interested in 1 month, for instance, if you're interested in 1 month, instead of making it 01, then bringing the other string here, 2015-06-31, no, /30 like this. You don't actually have to do it. If you specify it only with that particular number, the system will actually know that you want it for the whole of July. If you want it for 2 different months, you just have to bring the comma, then use the same procedure. So 2015 maybe to December. So the system know that you want to query it from 2015 June to 2015 December, and it will do that query for you. If you are interested in between 2 different years, just specify only the year. So if I'm interested in 2017. So 2015 to 2017, it will give you all the years from 2015 to 2017. If you make it June, so you're going to get the salary image from June 2015, 2016, and to give you all the years for 2016 and 2017. So these are some of the things you can also take notice of. Instead of typing a lot, you just specify the time frame that you want using this procedure. Unless you are actually after a particular date, which you already know, you can actually bring that date also there, maybe maybe on the 12th of December. So this one will load a particular date, the date that you are working with. It's actually going to load that here for you. And the dash chunk. So the dash chunk will actually, the amount of data to load at a particular time. So what you are trying to tell him is that he has to load 10,000 pixels for the X and the Y at a particular time, so that it actually makes our loading quite quickly. So if you are going to do with 2015, 2019, you're going to have that time frame. And from 2015 to 2019, because you are using dash chunk, the dash chunk will load 1,000 pixels at a time. That's 1,000 pixels at a time for us, so that it will actually load, use up all the memory that we have. Then we'll come to the load ARD. So the load ARD function is actually the function that loads the data base from the system onto our system's memory. When you are talking about the system's memory, if you check down here, you have the memory here. So that's the system memory we are talking about. So for this system, you have about 15 gig available for us. So anytime you are loading a database from the system, it actually stores them within this memory. So right now I've used about 6.48 gigabytes of memory. So I have about 8 gig of memory available. So if I don't want to use much of this memory, that's when the DAX comes in. So with the loading of the data, it will load them one at a time so that it won't actually use up all this memory. Then we have the mean good data also here. So the mean good data actually clears up so we want 75% of image cloud free. So the images that you are requesting, 75% of that image cloud free. And the measurements. The measurement is very, 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 very important. Let me comment this session and I will explain why the measurement is very, very important. And every time you have to include the measurement. You have the product here. For this particular product, you are using the Landsat series, the Landsat C. So let me run it here. Oh, okay. So you have an error here. So the African Landsat collection has been upgraded. Use the collection to product name. So normally, if you get an error, please try and look at the value error side. That actually gives the type of error that you are facing. So you can also take notice of that. We are using the Landsat 8. So this is the new name that has been given. That's the old one. You can click it there. Then let's execute it. So we are now using the DAX to load it up. The DAX, that's actually loading it 1,000 by 1,000 pages. It's actually going to take some time to load it for us. So now let's see what will come. So I'm loading it from 2015 to 2019. And the data that I'm actually after is the resolution is 0.75. So the system is doing that query within the database to bring me the results for the area that we are working with. So while this thing is still loading, let me also add this one to it. Please, for the existing notebooks, anytime you want to work with it, try and duplicate it. How do you do that? So for instance, the water extent notebook that I'm working with, because I use the same notebook that I'm working with it here, if there's any changes that will come, and we update it on the master branch, it will overwrite the water underscore extent notebook. So all the work that I've done here, I will lose them. There's no way I will be able to get those results back. So it's always a best practice to duplicate whatever we are doing. And the way to duplicate is to right click here, then click on duplicate. So once you click on duplicate, a new notebook will be developed for you, which is the water underscore understand underscore dash copy one. Then you right click on it, then you can rename it. So the one you want to work with. So I'll rename this one to Lake Edward. Okay. So anytime the master branch is updated, the water extent notebook will be updated with the new parameters, but the Lake Edward won't be affected because I've already make a copy of them. So anytime you go into the system, you continue to see that folder that you have. Okay. So the data set is loaded. So please, when it's loaded, take notice of this particular session. So there were 113 time steps that were returned. And out of the 130 time steps, only 44 met our criteria of the 75% that we had. So if you look at the time series, you had 44 imageries coming at that particular time. If you look at the bands, you have the red, green, and blue bands, and you can see that they are all in a dark array. So we are loading them 10 by 10 pixels at a particular time. We're not actually loading all of them into the system memory at that particular goal. Red, green, blue. Because you specified the measurement, that's why we're having the red, green, blue. Suppose we didn't specify the measurement, what would have happened? Let's change the resolution to 95. Right, the data will actually load quickly fast. So we are changing the resolution to 95 now. Sometimes when you are running, you are going to see some of these warnings. You can ignore it. Once the asterisk is still running on a particular cell, ignore the warning. It's just a warning. If it is an error, the asterisk will change to blank like this. So normally, once you see some errors, like just an error to give you that maybe in the near future, particular products will be upgraded. But once it's still running, you can just still wait for it to run. And we've also increased the resolution to 95%. So that means the number of images that will return will also reduce for us. So let's see the number of images that will return. Whilst it's loading, please feel if you have any question, please you can ask. Okay, perfect. So right now it has shown up. So what you see right now is the x-axis, all the measurements were actually also loaded up, and actually that also takes a much of the time. And also have the dash array also here. So for the Landsat 8, we're able to see the red, green, blue, the infrared, shortwave infrared, and the shortwave infrared 2. You have the pixel quality and you have the radiometric saturation. So if you don't specify the measurements, all these measurements will be uploaded for you. And once it's uploaded, it actually makes it difficult to use a lot of memory, especially if you are not going to use any of these measurements. If you use Sentinel, you'll have seen that the center, if you didn't specify the measurements, you're going to have 01, B01, B02. Let's use the Sentinel product and see the result that will show if you use Sentinel without specifying the measurement. Let me reduce the, let's use for only 1 year so that it can actually load fast. So non-type object has no attribute measurement. Okay, let me get the name correct. So right now I want to get the name of the, I think the name of the Sentinel, I have to get it correct. And to get the code for the Sentinel, I have to visit the explorer.digital.africa, which will give me the code for the Sentinel that I have. Actually, I can also get the code from the DA African map by going to the Explore, and I click on the satellite imagery, go to surface reflectance, go to the annual surface reflectance. Then I'll choose the surface reflectance at this session. So on the left side, on the right side, wait for the information to load. Then I'll scroll down. So that's the layer name. So this is the layer name, the S2 underscore L2A. I had the name wrongly. Or I can come to Explorer. It gives me the data, metadata information. And I can also copy the layer name from this particular session. So if you click on the Explorer, all these names that you are seeing here are layer names that you can actually use within the sandbox to connect to the particular data set you want to work with. I provided the wrong name here, so let me put the correct name here, and now let's execute it. No data available for the query. So the area that I specify, I think the resolution, the mean good data is too much. Let me reduce it. Okay, let me add A's. Sentinel starts from 2017 and I'm using 2015. So that's why we are getting this error. That's why error is coming, no data available for query. Ensure that the product specify have data for the time and location requested. So it's just trying to tell me that I specified 2015, but the year actually, Sentinel actually starts from 2017. So from the metadata, you actually know where, if you click on the all years, you know where this thing, the Sentinel data actually starts from. So you don't have 2015. So let's make it 2018, and now let's execute it. So we want about 50% of mean good data for Landsat. So you can use this run to execute a particular cell, then this to interrupt a kernel. So for instance, I noticed that, okay, I should have gone for 0.95. Then you just first have to stop the kernel that is running by using this one. So once you click on it, it will stop the code and you're going to get an error message here. Don't worry, because the thing was running and you interrupted it, it will give you an error. But just stop it and click on the run again. Then it will rerun that particular cell for us. So we wait for it to reload. Remember, with this particular line, we didn't specify the measurement. We forgot, we just uncommented the measurement. Let's see what will happen. It actually takes some time, but because you've actually increased the mean good data, you are going to get a really good result for the Sentinel image. And sometimes also, depending on the internet connectivity, if it is very fast, the data can actually load fast. But if it is average, it will actually take some time, but it won't take much of the time like that. Because this one you are specifying for the whole of 2018, it will take some time for it to load. So whilst it's loading, okay, so it's done. Perfect. So for this particular time step, we have about 7 time steps, but only 11 was able to reach the criteria of the 95% good quality, which is cloud free. But because we didn't specify the measurements, look at the variable names that actually showed up here. So we have the B01, B02, B03, B04, which can actually also get confused along the way. So to prevent this, that's why it's always a good thing to always specify the measurements. Then specify the bands that you want, especially with the real names that you know, the red, green, near infrared. Let me reduce this one so that it actually took much time. So I'm not looking to only 1 month, that's 2018 January, so to actually load faster for us. Then let me execute it. Yes. So within January, we only had 2 time steps. Because we also specify the measurements, right now you can see that we have the red, gray, and blue available. So mostly for the already existing code, these are some of the areas which is actually important to work with and to change so that at the end of the day, you get your results. So right now that these parameters have been changed, we've been able to identify our area of interest. We've known the satellite imagery that you want to know. Right now that we make the amendments within these 2 areas, it is actually most crucial for existing code. The next thing that you can do is to click on the forward button, this forward button just after the code, is to click on it. So let me check the area. So this one, 2015, 2019. Then let's restart. So once you click on it, it will restart all the cells, then run it for you. Once you click on this double forward here, or you can come to the kernel, then you choose the restart and run all cells. So once you choose the restart and run all cells, it will run everything from 1 to the end of the code for you to have the results. I think there's an error somewhere. There's an error. Load wolves. So there's an error here, line 9. Okay, so this is a comment. So you're supposed to comment it. That's why I say invalid syntax. You're supposed to comment it, but I uncommented it. So once you make that changes, you can click on it, restart kernel again, and run it. So once you click on it, you notice that all the cells have asterisk in front of them, meaning that it's executing. But if you go through, then you realize that the asterisk is no more there. That particular cell, this particular cell is blank. That means there's an error along the way. So you have to trace back to the error phase and work with it. Okay, so this is how you can work with an already existing notebook within the sandbox that you can work with, and using the latitude and the longitude. We also talk about the 2 ways that you use the centroid or you define your own bounding box, and how you can also load your satellite imagery using the load ARD system and the query. The amendments you can actually do in the query to make your data load fast. And also we also talk about the DAS chunk, the parameters that you've explained there. And we also talk about why the measurements are important. If you don't specify the measurements, all the measurements will be loaded for you. And if you are using the Sentinel, even the band numbers will rather be used instead of the band name. So the B01, B04. But if you specify it with the correct names, you are going to have that And it also makes your code much more easy to read and easy to work on when you are working with. Okay, so these are some of the things that you cover today on it. So after making these changes, you execute all the cells again, then it will run everything for you. Then you get your answer, you get your results. Once you get the results, that means you are done for that. Next week, we'll talk about how you can use a shapefile or a JSON file. If you already have the area of interest, how you can actually import it into the sandbox and work with it using the same example we did today. Thank you. Over to you, Ken.
Thank you very much, Edward. We're actually clapping for you. This was the best presentation ever because you've taken us step by step. We are very grateful also for the participants who've joined us. This is the time to pick any question from any of us. Questions welcome.
Mine actually is a comment. I think now I'll just like to echo what you just said. The step-by-step with each reasoning in each line, I think it's quite informative, giving us a little bit of edge as compared to the normal running of scripts without knowing when to pull the data and how to pull it. I think probably as we proceed to the next session on how to call some of these data sets, it will be a very good way to show us directly how you pull a shapefile, maybe an image, as well as a .json file. Thank you.
Thank you very much, David. Any other comment for Edward or Professor Edward and August?
No, great presentation, Edward. Thank you.
So thank you very much, Edward, for this great presentation. I also wanted to add something because I can see we have a few seconds. This very much important resource for everyone. This is the DE Africa user guide. I don't know how many of you have looked at it. So it has step-by-step information, even on the sandbox. So for example, if you click on the sandbox, it will give you the step-by-step. So actually I went through the note galleries, and pretty much what was presented by Edward was one of the examples in the real world examples. So you can actually even click there and see what is there. It can be also a nice tool when you're exploring the various notebooks that we have. And I remember Stella was asking for a notebook for vegetation phenology.
Yes, I was asking for a notebook on vegetation phenology.
Were you able to see it because Edward guided you on the exact location?
Yes, I was able. So I think also one of the things that Edward said was that we save the notebook so that we don't add changes on the original one. Maybe just one more question, Edward, is whether we save the exact notebook in the exact place or we can create our own subfolder.
Okay, Stella, so you can duplicate it within the same folder, or you can create your own folder, then duplicate, then the copy that you make, you move it to that your folder. Anyhow you want to do it, it will work.
Thank you very much, Edward. I'm also posting again the link to the user guide, and I can also go back just in case there's something you might have seen. And I was trying to look at Edward's example, which was very nice. And if Edward, if I may show something, is it okay with you, sir? So
yes,
I was looking at one of the colleagues who've joined from Sierra Leone, and we had the issue of cloud cover. Was that correct, Bashiro?
Yes.
Yes, so DE Africa added some data on the Sentinel-1, and I was trying to see what Edward was presenting, and there's a new notebook on the same, which now uses Sentinel-1, and I was able to run it for Lake Mabesi in the south of Freetown, south of Sierra Leone. You remember this area?
Yes.
And I used images for the year of 2000 using the Sentinel-1, and it was able to show very interesting results. So it's similar to what Edward has presented now using the radar data, which Most of us understand the radar uses different frequencies, and these are different polarizations. And using different filters, like the Lee spectra filter, you're able to come up with some very good numbers. And if you convert them, you're able to filter around and come up with the threshold for water. And that's the result using the Sentinel-1. I just wanted to point out that because Bashir has joined after very many months, and welcome.
Yeah, sure. We had internet challenge previously in the office, and there were a lot of office issues that were coming up. That was why I was absent. But I am out of office today, so in fact, I have an exam by Thursday. I saw the link. I said, oh, it's been a while. Let me connect today. And because I saw you posted that I will be presenting water. So I said, let me join this session today so that I'll be on track.
Thank you so much, Bashir. I hope this presentation was okay. And I'll also post this notebook in the chat so that you can actually look at it. I'll post it in the WhatsApp. You're still a member in the main group?
Yeah, I'm still a member.
Okay.
I will follow. I saw the link on the WhatsApp group and the other thing that you were sending.
Thank you so much for joining us. And this was just for you. I had to do this for you to see that there's something for Sierra Leone even using radar. Thank you so much, Bashir, for joining us.
Yeah, I want to ask, is there anything about mangroves on the sandbox, on the Dear Africa platform?
Yes, we had this notebook on the mangroves. This was the frequently used code. And I remember very well, there was even another one where we were using the geomedian. And that is coming. So I'll be able to send you this particular example we did for Zanzibar. And I think it can work for Freetown and the small island around Lungi. This was the area of Yumba. The two areas which used to work very well with Samuel Kamara on that, I remember very well. So I think this one will be able to modify it for you, and it will show you that. Then where there was still another notebook on mangroves, which I know Stella has used before. So this one was similar, and we can generate something and put it in the chat to keep the conversation going. So thank you so much for connecting with us, Bashiro.
Thank you very much.
Okay. Anyone else with a question? Anyone else with a comment? Welcome, Amadou Sal. Welcome, Bako. Thank you very much for joining us. It's never too late. And also welcome very much, Wallace, after many, many months. I trust you've been well.
Merci beaucoup.